I will start from a question. Have you ever thought why these things are not called the same? I will answer this question. My name is Vladyslav Hesal. I'm Ruby and sometimes JavaScript developer. I'm also a world-class procrastinator. What does it mean is a topic for another talk. And this is some of my context. I don't use Twitter, so please don't try to reach me out via Twitter. And also, I work for Svitla, which is an organizer of this great event. And the topic of my today's talk is authentication in single-page applications. But this talk is not specifically about this, but about the approaches of how you analyze problems. For example, we always had authentication in regular applications, and they came single-page applications. And how do we know what approaches we should use and are they secure? So back to this question. Actually, it's quite easy to answer why the things are called the way they are. We need just to look at the dictionary. So authentication is the act of proving that something is real. Authenticate is to prove that something is real. And authorization is some permission or something that proves this permission, like a document or maybe some token. And authorize is to give permission. So now it's clear. When server says www.authenticate, the server just says to you, please prove who you are. And when you send authorization header, you just says to the server, there is my permission. There is the proof of that permission, like some token, the document. And when server says unauthorized in the response, it just means that server did not give you the permission, either because you did not prove who you are, or that whatever you provided does not give you the permission you're asking. Authorization header, like the beloved way to implement authentication in single-page applications. People often say, like, it's a clear way, like the same as in mobile clients, but is it really? Let's think about it. In mobile clients, we have the device, some operating system, applications, and our applications. By the way, this fox is called Ferdinand. It's from Telegram stickers. But in web applications, it's kind of the same story from the start. Some device, some operating system, but then there comes user agent. And it actually changes everything, because all our applications live within user agent. And web applications are hypertext, like all the web is hypertext, which means that applications can talk to each other via different means. Applications can load arbitrary resources, execute arbitrary code, like JavaScript, request images, other pages, embed iframes, and all this stuff, which is not exactly like in mobile apps. So when we use authorization header, it's not exactly like a clean API approach. And there are two most common vulnerabilities in web applications. So let's just analyze if it's secure from these two perspectives to use just authorization header when you're implementing authentication in single-page applications. Actually, there is quite a nice way to think about cross-site request forgery vulnerability, because there is this thing called cross-origin resource sharing. And in its spec, there is this simple request, which basically describes whatever browsers could already do before CORS was introduced. It's quite amazing. Like, there is one place where you can see everything you care about regarding cross-site request forgery. And the document says, like, you don't have to read all of it. Basically, it says that you have few methods like getPost, few headers, and few content types. And if you see, there is no authorization header here, which means that if you use authorization header, your request is not simple. And if your request is not simple request, browser will not do it without explicit permission from the server, which means that other applications cannot include authorization header to the request to your application without explicit permission, which basically makes CSRF impossible when your application completely relies on authorization header on the backend. That's just a simplified version of what I said. And actually, there are a bit more quite nice passive anti-CSRF measures, like put, patch, and delete methods also cannot be considered simple requests, so that's also cannot be forged. Any custom headers cannot be forged. Custom content, like not custom content types, but more special content types, like if your application accepts only JSON, this also cannot be forged. And also you can check refer and origin headers, because browser just has to include them in requests. So, as always, some issues with UTF-8 symbols. We are good with CSRF stuff, but there is quite a bigger concern in single-page applications, which is cross-site scripting. Like, the whole applications is a big piece of JavaScript. And so if you're concerned about XSS, you're quite right, because basically any XSS, if it's somewhere in the applications, it potentially can reach to any other part of the application, because the user never leaves the page. And often when you ask people about XSS and how to defend against it on some forums or Stack Overflow or whatever, people say these things like, if you have XSS, you're basically doomed. You should prevent it in the first place. But is it? Are you doomed, actually? Let's divide XSS into two types. The first one, when you can access credentials, like your authentication token, session, or whatever. And the second one, if JavaScript cannot access authentication credentials. And actually, it's not the same, because in the first case, it takes much more effort. Sorry. In the case of active XSS, when you cannot access credentials, it takes much more effort to do anything useful with that vulnerability, because user need to be online, attacker need to interact with the page to do like whatever requests attacker wants to do. Because the only way to access backend is via a browser automatically including credentials. But if you can just simply steal credentials via JavaScript, you can just use them off-site. You can write a very simple piece of JavaScript code, inject it on some site, and do whatever you want with those credentials. You can gather like 1,000 of users and gather a lot of data. So recapping, is this simple table? It's more dangerous to have credentials open to JavaScript, which is the case when you use authorization header, because you just have to have those credentials somewhere to use them via JavaScript to include into each request. But we can still think further about that. Like when we're talking that there is an attacker and the victim, the thing is that someone injects some code to access someone else's session or credentials. And we can think about it as a responsibility scope. It completely depends on your application, but just for example, let's divide it into 5 scopes. There can be guests, like you have a single page application, it's open to everyone can just go to it and do some stuff. There can be users like registered users. So you have to log in to access additional pages in the application or additional functionality. Managers who can probably change some information, like change user post or have to review or moderate user post, and some kind of admins who can do a lot of things. And the thing is that very often single page applications are does not have guests in them or many of scopes. Often this is some internal thing which is used by a very limited set of users, like maybe it's just 20 people whose job is to review content, and your single page applications is also a completely internal thing, and no one else except those 20 users uses it. And in that case, there is no one to inject this JavaScript into some content which then would be rendered to someone else, because all these people do the same job. It's makes no sense for them to inject their code into their colleagues, like they won't steal anything more than they already have. So if your attacker scope is more than your victim scope, then it's kinda not good, but not that bad. But if attacker in the lower scope and can inject, for example, if a guest can inject some code and it will be rendered for admins, like on their admin review page, then it's very bad, because basically you have a vulnerability where any user can break into admin's account. So when you're using authorization header, you need to put it somewhere in the web storage, which is always accessible by JavaScript. We are completely safe on CSRF side. We are kind of not good with XSS, which is used actively, and it's terrible because everyone can just steal this access token from web storage. But as I said, all this completely depends on how actually your single page application works. You should carry it by yourself, by understanding how wide is the scope of users you have. What we can do about that red and yellow stuff here? We can provide short-term credentials, which would ultimately lead to users have to authenticate again, which is actually not quite user-friendly, and often management won't let you do that actually. They want that sessions are basically infinitely long, like for 60 years. You can use refresh token, but you cannot put it in web storage, obviously, because if you do, it will be like we are back on this page. So we'd have to put it somewhere in cookies. But why do we need to use authorization header in the first place if we are already talking about using cookies? This is the recap. So web storage, short term, for access token, And if you're using refresh token, it's HTTP-only cookie. It can be long-term, but it's cookie. Anyway, requirements can be quite different. In single-page applications, it's like totally possible that you have microservice architecture, and you have no other way except for using authorization header because you have a single token for 5 or 10 different services. And it's not architecturally possible to use cookies for each separate domain. Okay, then it may be quite feasible to use refresh token when you refresh within a single authentication service and use short-term access token for all the other services, which is kind of exactly the way that implicit or auth to flow works. So when we use an authorization header, we're completely fine with CSRF, but it depends if we are fine about XSS. So let's try to make it more secure with cookies, because from what I said at the beginning about difference between mobile clients and web clients is that mobile clients often have some secure storage for tokens. And the only secure storage for web clients is HTTP-only cookies, which cannot be accessed by arbitrary JavaScript and is automatically added by the browser to all requests. But we are back with the problem of CSRF, obviously. And we're like back to all the problems prior to single-page applications again. So like, in one hand, we have a great, cool single-page application, but on the other hand, we cannot make it quite nice because there are possible vulnerabilities. And it may seem like I'm quite confident about talking about XSS, like if you always have it. But like on practice on large projects, it's often quite hard to prevent it completely. Like from time to time, there's often this small place where is this unfiltered input from the database goes right to the page. And like, does someone know absolutely guaranteed way to prevent the possibility to inject arbitrary scripts onto the page? Yeah, that's it. There are a lot of countermeasures for CSRF when you have cookie auth, when browser automatically sends requests, which some of them I already mentioned. It's custom headers, like a custom header already means that this is not a forged request. There is double submit cookie, which simply means that you send some value, you have some value in the cookie, which can be absolutely JavaScript readable, but you also include some value within the request or a header with that value, which kind of when you have header, you already prevented CSRF. There is this synchronizer token, which basically is the thing which Rails use, so you're quite familiar with that one, and encrypted token, which also the things that Rails does, because Rails encrypts the token. So with the latter two ones, you're already familiar. Okay, so let's say that we have the single-page application, and we like get rid of this authorization header because it's like total bullshit. It's not completely secure, and we switch to cookies. We secure against CSRF. All this cannot be stolen. Can we make it even more secure? We can make it even more secure with content security policy, which is rather fascinating thing because it says browser what browser can do and cannot do. Like it exactly solves the problem of cross-site scripting, but actually it's still tricky to use it nowadays. because if you use a modern framework like Angular, for example, Angular does some very nasty dynamic stuff in the runtime, and often it fails because it tries to evaluate some random piece of code, and you would have to include this hash of that piece of code, and like every time you change anything, you would have to update this stuff. It's like not all applications can use this to the full extent, so we still might consider the things I said previously. Just so you know, content security policy has quite a great support in browsers, and I see like there is this first version with a bit small set of features and a bit more features, which still has a quite great support. I see absolutely no reason to not use it. And the great thing about that is if we use content security policy, we're secure in both cases. No matter if you really need authorization header because you have microservice architecture or something, or if you have cookie auth because, for example, you have a Rails application and you don't want to reinvent anything new, you just use sessions, you're completely secure because with cookie you can just provide CSRF token or whatever other passive measure, or just use whatever Rails gives you. And with authorization header, if you set up CSP correctly, attacker has no way to steal your credentials because you just forbid requests to any other site. So like there is no way to steal credentials out of the application. And even if attacker does some requests, he cannot get the result out of that. What if we want even more secure application? Like, it's completely secure, but we want even more secure. There is this interesting trend among applications to use a completely separate login page. Like, if you just pay attention. If you log into Google, Twitter, LinkedIn, GitHub, DigitalOcean, Amazon Web Services, and a lot of others, you get a separate page with a login form, login password, which is like in no way connected to the main, like your panel, other site functionality. And it always loads from the scratch, even if any of those have quite a nice single page application, so you never have a page reload whenever you do anything on the site. When you log in, you still have a separate page. And I always wondered why do they do that? And they do that precisely for the previous reasons, because if in any place on that site there is a possibility to XSS, page reload would just wipe it. So there is no way to inject a script into that login page, which would steal the most valuable credentials, your login and password, which is not like some abstract token which just lets you something. Your login and password just lets you everything. And you might consider this very interesting practice if you need like a really great level of security. And you can also completely separate the domain where users basically change anything important in their profile and where they log in. The only known example to me is Google, which just uses a separate subdomain for anything account related. But the reason to do that is because besides a few vulnerabilities as described, like CSRF and XSS, there are some others related to cookies. Like, for example, you can overflow cookies from a subdomain and actually alter cookies on a parent domain or another subdomain. So it's not even necessary to have XSS or CSRF on the actual domain you're trying to attack. You can somehow alter cookies on that domain by other means. if there are some other domains. And by doing the separate domain, you kind of eliminate this issue, because if the domain is deeper, then it's kind of not possible to overflow the cookies. I mean, deeper, like it's more nested than the original domain, like accounts google.com. You cannot overwrite accounts google.com from like www.google.com. And after all that I said, because this is obviously a Ruby talk, let's recap how we can apply this to Rails. Like, very often I get a question if is Rails applicable for single page applications, whatever Rails does. And actually it does, for quite a great extent. Because what Rails does is Rails already uses session, which is based on cookies. They are always HTTP only, so they are not readable from JavaScript. Besides all this stuff, Rails automatically cleans up any scripts from output, but as I said, it's like hard to completely guarantee that you don't have XSS. Rails uses encrypted token approach against CSRF. So it's not only not possible to steal the token, but also not possible to forge it via other means.